Good afternoon to all and welcome to our third session for Asia Water 2020 Technology Symposium. Before we start, there are a few rules that we have to adhere. All microphone and video of attendees have been muted. If you have any question, please wait for the Q&A session or you may list them down at the Q&A box. If there is any internet disruption during the session, kindly be patient and try to sign in again. In this session, we will have Mr. Simon from Wehrle to do the presentation. Mr. Simon, after his study in the process and environmental engineering at the German university, he started working at Wehrle as a project engineer for the Asian market in 2009. Within the years, he was responsible for the realization of many wastewater treatment projects for well-known clients in Asia and the Middle East, example for IRPC and PTT in Rayong, Thailand, for Mans and Gesser and Effluent in Kuala Lumpur, Malaysia, etc. Besides the planning and design of different industrial wastewater and leachate treatment plants, he worked on site by commissioning the plants. Since 2018, Simon acts now as area manager for Asia and the Middle East region. With that, ladies and gentlemen, let's welcome Mr. Simon to do his presentation. Sir, the floor is yours.
Yeah, hello everybody. Welcome to my presentation, Next Level Industry Effluent Treatment. My name is Simon, as introduced. I'm working now since 10 years in Wehrle company, and today I would like to tell you about wastewater treatment by Wehrle. So we start more in detail. I would like to highlight you a bit about some company facts. So Wehrle is a 160-year-old company nowadays. In the 6th generation of the family, we have around 220 employees. We have an equity ratio of 50%, and our annual turnover is around $40 million per year. So Wehrle covers actually 3 divisions. We have the energy technology. The energy technology is doing engineering for boilers, steam boilers, for example, incineration plants, boilers for incinerators. We have our own manufacturing where the boilers gets manufactured, where the pipework for wastewater treatment plants gets manufactured, and we have the environmental technology sector. This is where I'm working in. We are active in 5 continents all over the world. We are acting almost in all countries. We are started with leachate treatment. Landfill leachate treatment. Leachate is a liquid which accumulates under landfill site, which is one of the harshest liquids you can find in the world, with high TDS, high chlorides, really toxic substances. And there we do the treatment since more than 30 years already. Successful, more than 330 projects all over the world. And from that perspective on, we started also to do industrial effluent treatment in almost all industrial applications, from food and beverage to pharmaceutical to petrochemical to dairy wastewater, so all kinds of wastewaters. We do also zero liquid discharge projects. We do our services and upgrades in our in-house, and we have own laboratory in-house as well, where we can test wastewaters before designing plants. So when we talk about industrial effluent treatment, we do not look only into the effluent, we also look into the industry, into the production, where are wastewater streams which we, for example, can reuse, where it makes sense to reuse water for the production of water supply, so that a factory can get independent of the normal tap water, for example, and the overall target is reducing the water footprint. So when we talk about effluent treatment from industry, we call it a normal on-site effluent treatment and the smart effluent treatment. So what usually many companies do is they collect all wastewater streams, which contains, for example, sanitary wastewater, medium loaded wastewater, high loaded wastewater. That results in a really huge wastewater stream. And therefore the plant gets really big because there is a really big hydraulic load to treat. So what we are doing, the smart concept is we do a water mapping and we are looking into the industry. So we try to find out what is the really high polluted stream. And then we are treating only this stream. That results in a much smaller plant because the flow rate is much lower and much smaller, but it's really polluted stream. And when we treat this stream, there is almost 90% of the overall wastewater treated because that particular small stream has the highest loading in COD, for example. That makes a really compact and small plant, which Wehrle stands for. So here you can see typical pictures of our plants. These are typical, or that are probably pictures. When you look at this, you would not expect that there is a wastewater treatment plant. So we do not work with large sedimentation tanks or large aeration tanks. So we build really compact plants which can be directly integrated in the industry. We build vertical plants. So in the middle picture and the big one, you can see, for example, a plant directly located in the neighborhood area. So that means there is no odor, there is no noise. So therefore, the plant can be located directly in the industrial process and don't have to be installed in a big industrial zone. If you look to the left bottom plant, there you can see a plant from Thailand, from petrochemical factory, where we are treating wastewater, which contains a lot of toluol, a lot of benzol, so very toxic substances, and we are treating this with a biological system. When you look to the left top, the high tower there, this is an anaerobic plant from our client Unilever in United Kingdom. They are producing ice cream there, and there we have a big EGSB plant where we are producing methane while treating the wastewater. So the next slide here, you will see a typical schematic drawing of our plant. As mentioned, we do not use the really big tanks. So we are having a aeration tank, which is usually 8 to 9 meter high. So we are working with vertical systems up to 12-meter water level. And this can be done because what you can see in the aeration tank there, this is not a membrane aerator or something, that are so-called jet ejectors, which you also can see behind me. Jet ejectors has the big advantage that they can work in very high water levels, so like 12 meter. Therefore, the oxygen bubbles which they are producing gets very fine. Therefore, the alpha factor gets very good. So the transfer rate from the oxygen bubble into the microorganism is quite good. Another big advantage of the jet ejectors is they can run up to 20 gram per liter MLSS bacteria concentration without clogging or something. That means we can pack twice the bacteria mass in one reactor. So therefore we save double space. Another important factor in our plant is the biomass separation, which you can see on the right-hand below side of the slide. So that are the ultrafiltration modules. They are dried, installed outside of the tank, not submerged, so they don't block, they don't clog. We have dry installed circulation pumps, which pumps the sludge out of the aeration tank through the ultrafiltration modules. In that modules, the clear liquid, the clean liquid gets separated from the bacteria and from the biomass, and the biomass returns back into the aeration tank. So these ultrafiltration modules can handle also up to 20 gram per liter concentrated biomass without clogging, without fouling. And another big advantage is the high flux rate. So these modules usually we run up to 120 liter per square meter an hour, which means that compared to a submerged system, for example, where the flux rate is 20 liter per square meter an hour, that we need 5 times less membrane area, so 5 times less replacement costs, which has a big impact on the operational costs of the plant. Also, we need 5 times less chemical consumptions during cleaning process. And really important is also in industrial effluent treatment, while CIP cleaning, each loop after another gets cleaned. That means we don't have to stop wastewater treatment while there is any cleaning in progress. This is a typical schematic drawing of a plant from us. So we have a balance tank where we balance the concentration of the industrial wastewater, then followed by the biological tank, by the aeration tank, where COD degradation takes place. And then we have the external ultrafiltration module. What you also can see here, that with this completely suspended solid free effluent stream from the ultrafiltration, it's really easy to connect the nanofiltration or reverse osmosis or any polishing unit for water reuse, because there are no particles inside. So if the client in the first step would like to have only a normal wastewater treatment plant to treat COD, for example, but afterwards, after 2 or 3 years, he want to install a unit where he can do water recycling, then it's quite easy and modular to adapt. This is another important factor. So what we see here is a chart of a plant from us, from Unilever in St. Petersburg. And really typical for industrial wastewater is that the inlet concentration in terms of COD and the wastewater amount is really fluctuating. So you will never have a constant flow, because the industry, sometimes they produce a different product, or they having a change in the shift or something like this, which directly has influence on the wastewater characteristic. That means the system has to be very robust, that it can cope with varying inlet concentrations while having constantly stable outlet concentrations. So the blue line, you can see the varying COD, and below the purple line, you can see the very stable COD discharge, and on top the green line is the degradation efficiency. You can see it's always between 90 and 100%, even by varying inlet concentrations. Here is an example from an upgrading, revamping project that we did. So the blue marked area is the area from the existing old plant. So you can see that was consuming a lot of space. After we won the contract, Wehrle installed a wastewater treatment plant on a really compact area. Is the green rectangular part, what you can see there. So you see in terms of space, it is quite a big space-saving factor. Also quite important, here you can see the green rectangular part was the area where Wehrle built a new plant, and the blue one was then an upgrade of the plant 2 years later. So it's quite easy to upgrade our plant since it's a modular design. To summarize the highlights and the benefits of the Wehrle plants in terms of industrial wastewater treatment, it's quite important that the plant is able to run on a dynamic operation, which means that it can adapt automatically to flow rate and to varying inlet concentrations. Also in some productions, for example, in petrochemical wastewater treatment plants, sometimes they're coming oil shocks or heavy metal shocks. So that means the plant has to be able to handle that kind of shock loadings, because there's always the discharge standards which have to be fulfilled in 24 hours and 7 days per week. Another point that quite important is the modular design. Often industrial clients increasing their production. That means the wastewater amount is also increasing. That means the wastewater treatment plant has to grow with the growth of the production simultaneously. And of course, it shouldn't be a big issue, and it shouldn't take weeks until the wastewater treatment plant is upgraded, because that would interrupt the production, and this is really expensive for the client. So a modular design with easy upgrading and expansion is quite of interest of the client. Another point is the easy operation. So usually our plants have a really high automation level. And also we equip our plants always with remote diagnostic. That means especially in the months after commissioning, we can easily connect to the plant, for example, from Germany or from Kuala Lumpur, where we have our subsidiary company in Kuala Lumpur directly. So we can connect via internet and can control the plant from the office as well. Here we have a typical schematic drawing of a project that we did in Russia as well. Was a zero liquid discharge project. So we see the biological system with the ultrafiltration as the membrane bioreactor unit, and then followed by reverse osmosis unit. The reverse osmosis unit is producing concentrate reject. So that reject we treated again in another reverse osmosis plant, so that we had a total leftover of 5% in comparison to the 100% inlet. And that 5% we were treating in evaporator. So when we do a mass balance from the 100% inlet, we had a total leftover of 0.2%, which was like a slurry, a liquid waste, and that is considered as a zero liquid discharge project. Zero liquid discharge is a big thing in the meantime now. Everybody talks about it. However, it has to be taken eye on from case to case if it makes sense, because if the process in the end is too expensive, and if it's more expensive to produce 1 cubic meter of zero liquid discharge reuse water, and when this is in the end more expensive than tap water, it makes no sense. So therefore it has to be clearly before the project, has to be done a water mapping, has to be checked if it makes sense or not, if in the end the OPEX price for 1 cubic meter reused water must be cheaper than the tap water price. Here again is kind of the small picture just to summarize. So 97.5% of that inlet water was reclaimed water and could be used for reuse. Only 2.3% sludge from the DAF unit, which was a pre-treatment unit, had to be disposed of, and 0.2% was considered as highly concentrated liquid waste. But the big important thing here is that the client could reuse 97.5% of his water. So finally, I would like to show some case studies from typical plants from us. This is a project, Menzengasa in Kuala Lumpur and the greater region of Kuala Lumpur. Menzengasa is an Italian jam producer who started its jam production in 2018. And of course, they are producing highly polluted wastewater. And this wastewater we are treating there with a performance of more than 97.5%, 8,200 milligram inlet, and the outlet is 200 milligram in the contract. Friendly speaking, the outlet values from the operators when they're showing us at the moment is less than 25 milligram per liter. The challenging part there was that it was quite a small footprint, so we had to build the plant into a really small area, and also it was mandatory to design the plant for easy upgrade from 200 cubic meter per day in the future up to 400 cubic meter per day. That one is French Chinese, FNN, also in the greater region of Kuala Lumpur, was conventional treatment plant. 60% was the flow rate that got increased in the future. It was not allowed to touch any civil works. It was only allowed to use the existing tanks. So what we actually did, we doubled the bacteria mass concentration in the existing aeration tanks without touching the civils. From 8 gram to 16 gram per liter MLSS concentration, and we installed external ultrafiltration loops which can handle that kind of concentrations. And therefore, plant was done. We increased a bit the aeration capacity, and the performance there in COD, BOD, and TSS is almost 100%. And the flow rate nowadays is 1,700 cubic meter a day. So here we see a plant in Bucharest. This is a chocolate manufacturer, sweet and chocolate production. They are doing like 5,000 milligram per liter COD in the inlet, and they are treating it down to 125 milligram per liter. This one is Unilever in St. Petersburg. This is the plant where I showed you before the chart with the varying inlet concentrations and the stable outlet concentration. Also here, there are a lot of detergents in the inlet concentrations, which we had to reduce by at least minimum 90%. Okay, this one is L'Oreal. L'Oreal is a cosmetic industry producer. And here it was mandatory to recycle at least 75%. So from 3,500 milligram per liter inlet COD concentrations, we could reduce it down to less than 15 milligram per liter, and therefore the water can be reused. We are not only recovering water, we are also recovering substances. So this was a project in Mauritius where they are producing sugar. Europeans, they like to have the white sugar, but usually the sugar is in brown color. So with this plant here, we are removing the molasses. The molasses and the brine both can get recycled with this plant, and therefore the client is saving more than 70 to 80% of its sodium chloride production. Last but not least, the petrochemical plant in Thailand, where we are, as mentioned before, treating benzol, toluol, everything with a biological system. And here we are treating almost 6,000 cubic meter per day of that kind of wastewater. So that was my short presentation about the next level effluent treatment from Wehrle. And now your questions are really welcome. Thank you very much.
Ladies and gentlemen, we have come to the Q&A session. If you have any question, please click on the hand raise function and we will unmute you, or you can list down your question on the Q&A chat box. Please make sure to introduce yourself and which company you're from, follow up by your question. All right, so there is no question from the floor. So we have come to the end of our third session today. We hope that today's session, you will get insight from Mr. Simon. So if any other inquiry, please visit Wehrle virtual booth in our virtual exhibition hall. That's all from us. Once again, thank you and please stay safe all the time.
Thank you.